Okay, so what was it? So today is still the 5th, right?
Yep.
And the function was f of x
Equals 4 plus x divided by 7, finding the inverse.
So 4 plus x
Yep.
divided by 7?
Yes, ma'am.
Okay, so the first step is y equals 4 plus x over 7. This is a proportion. In step 2, I have 7x equals 4 plus y. I have to interchange x and y, and I have to solve for y. And y equals 7x minus 4. And that's f inverse. These are the 4 steps. Okay. When we add and subtract, I'm not sure why you started factoring. And you factored only from some and not from everything. So careful with that. Okay. Any questions for me? Is there anything else you would like to go back to? Anything else? So here we had some questions last time. We looked at the distance formula, midpoint formula, the equation of the circle. So this was the distance formula. This was the midpoint formula. And then we looked at the equation of a circle, and starting with the distance formula, we created the equation of a circle. And we said there were 3 different types of problems here. We are given the equation, and we're asked to find the center and the radius. The second type of problem is we're given the center and the radius to find the equation. And the last one was completing the square for 2 different squares, one in x and one in y. And then we graphed several circles. Then we looked at quadratic functions. And we said, okay, this is all a review, quadratic functions from the previous course, but I considered it not a review, so we went through graphing of a quadratic function each and every step, finding the vertex, x and y-intercepts, axis of symmetry, and then we graphed it. What I would like to do today is look at the other form in case we are given this, which is easier. Why is it easier? Because we know transformations. So this will be easier. But the same steps we have to present, all the same. And then I would like to look at word problems, and then move on to polynomial functions. But not before I answer your questions. Anything you'd like to? Yes, please, Marcus. Number 1 from, okay. As I said, the solutions are posted.
Oh.
But is there a particular one that you want to go over? Is it the sum, the difference, the product, the ratio? Is it the composition, function composition?
No, I think we figured it out.
No, I don't want to do, yeah, yes.
The ratio?
Yes. So the ratio was f over g of x. And I do have somebody here. So this was negative 3x squared plus 6x minus 1 over 3x minus 6. You cannot do anything else other than write that x cannot be 2. So I expected a domain negative infinity to 2, union 2 to infinity. That's all. Now if we are asked to find f, what was it? F over g of 1, correct?
Yeah.
I believe. Was it?
Yes.
Okay, so then I have negative 3 plus 6 minus 1 over 3 minus 6. So 6 minus 4 is 2. 3 minus 6 is negative 3. So the answer is negative 2/3. Anything else? Anything else? Anything else? Okay, so let's go back to 3.1, but and choose a problem. So one more time, this is where we are. We're still working on these, and then we'll continue with 3.2. Okay? And then when we finish 3.6, we will schedule our second test. Initially, I thought that it would be a good idea to include 4.1 and 4.2, but I don't think it's a good idea. I think we should stick with the end of chapter 2 and chapter 3 for test 2, and these should be together. So now if you say, no, I think it's going to be too much, I'm fine. I will include 4.1 and 4.2. But I think that these functions are completely different, totally different than what we're studying in chapter 3. And the systems should be a breeze. Okay, so we'll decide when we finish 3.6. If we still have energy, we'll continue. If not, we'll say, okay, let's schedule the test. Okay, that's where we are. Okay, so on page, if you have your book, if not, I will choose a problem or I will make one up. I would like us to look at the other possibility. So a function can be given, a quadratic function can be given to us, like, for example, 12 on page 360. And this is f of x equals -2 x plus 4 squared minus 8. Before we do anything, let's just imagine what is the base function used for this, to create this function f of x. What is the base function? Is it the square root of x? Is it
X squared.
x squared? Okay, so what do I have to do first to graph x squared? First transformation on x squared. Awesome. Move it to your left, 4. Good. Then, not yet, I'm not there yet. It's so far away. Next step, in order of operations. No, not yet. It's not a mistake. Vertical stretch by a factor of 2. Then, awesome. And then, can anyone give us the vertex? One more time, let's start from scratch. X squared, 4 to your left, stretch, reflect, down 4. Down 8, I'm sorry. In my mind, this was -4. I'm sorry, let's do this again. I'm sorry, my apologies. I thought it was -4, not -8. One more time. X squared, x plus 4, 2 times x plus 4, down 8. You don't need me. You really don't. So -4, -8 is the vertex. So what is the difference from the other form? I'm given the vertex and I don't need to calculate it. That's the only difference. Okay? So step 1 is still the same shape. You already now have the graph in your head, even if we didn't graph it yet. So can anyone just give us the range of this function right away? Negative infinity 2, 2, negative infinity 2, -8. -8, right?
You said the range or
The range.
Oh, okay, they just said domain.
The domain is all real numbers, correct. Yes, Marcus, go ahead.
So it's negative infinity because A is a negative, so it opens down.
Already graphed the function. Yes, yes,
Oh.
yes. You're right. That's another way of explaining it. That's correct.
Okay.
Here, left 4, stretch, reflect, down. Good, so then the shape you already told me, A is a negative number, so it has to be a maximum. This is our second step with no effort. Step 3, X-Intercepts. You already gave me the range. What would you say about X-Intercepts? That's why I asked you about the range. What did you say about the range again? Okay, what are the x-intercepts? Of course, we're not going to waste our time. None. 4. Y-intercept. How do I get the y-intercept? This one is slightly more difficult. Slightly. How do I get the y-intercept? Awesome. Thank you, Tim. Wait, you are cooperating tonight. Are you okay? I know. I'm kidding. I'm sorry. I apologize. Okay, 0 plus 4. 4 squared. 16 times negative 2. Negative 32 minus 8.
Negative 40.
What is the ordered pair that we just determined?
0, negative 40.
0, negative 40. As you know, the other two and the last one you already gave me. So 5, 6, and 7. The range, you already gave it to me because you learned transformations. Bless you. So the range one more time. Negative infinity to negative 8. So 5 is axis of symmetry. Yes. But something equals negative 4, not just negative 4. Say it again. Awesome. And then maximum value of this function is, maximum value of function f of x is negative 8. Very good. So let's graph the function. How do I graph this function? What do I start with? Of course. Of course. Look what I do. Because I know where the vertex is. I don't care for the top. So you said negative 4, negative 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Right here. Then I draw the axis of symmetry. It's not a solid line. It will only help me keep the graph in shape. So this is x, as you told me. X equals negative 4. And I have the y-intercept. And I'm going to kindly ask you to say that this is 0, negative 40. I'm going to have a break in the graph here in the axis, in the y-axis, because this is negative 8. This is definitely not negative 40. So bear with me, and I will graph this side, and I'm trying to make it as symmetric as possible on this side. So this is the graph of f of x, negative 2, x plus 4 squared minus 8. We did not get the chance to look at any word problem here, correct?
Correct.
Thank you. So let's do it now. Okay, 58. On page 361. Because I would like you to understand how important the quadratic function is. So imagine that I do this. I have a ball in my hand, and I throw it up in the air. What do you think the trajectory of the ball would look like? Will it be a straight line? No. So what will it be? A quadratic function. So if I throw the ball, it will do this. It will reach a maximum, also called how? Thank you. And then it will eventually hit the ground. Okay, so let's read this problem. We are given a function, g of x, which is negative 0.04 x squared plus 2.1x plus 6.1. I'm going to ask you a couple of questions here. Number one, does this function have a maximum?
Yeah.
How do I know? Based on,
X squared.
no,
A.
based on the coefficient of x squared, which is negative 0.04. Because it's negative, the function has a maximum. Agreed? Yes? Okay, perfect. First question. What is the maximum height? And, I'm sorry? Say it again. Okay, so what is the maximum height and how far from its point of release does this occur? So this is the point of release right here. What is the maximum height and how far away does that happen? Max height is our first question. And how far? How far from the point of release? That's our first question, part A. Can anyone tell us or walk us through what we need to do here?
After you use the formula b over 2
I need to use, say it again.
negative b.
Why do I use negative b over 2a and I don't just read the vertex from this? Because it's given to us in the first form, not the second form. If I were given the second form, I would have determined the vertex in a blink. I would say left, right, up, down, flip, whatever, and I would have gotten the vertex right away. But I can't. So I have to do this. Good. Can anyone dictate the next step? Negative is in front. How much is b? And be careful. The function may not be given to you in descending order. What will you do first? If it is not given in descending order. Yes, you must. You must. Okay, so 2.1 is at the top and the bottom is 0.08. 2 times a. I multiplied this by 2 and I got that. What is the answer we get? 26.25. And the measurement unit, I didn't, what was that? Feet, yes. Can anyone explain what does this number represent?
How high up the axis is? The axis of symmetry.
The vertex. So the maximum height.
I didn't get to the maximum height. The maximum height is given by the function. Marcus is right. He said this is the axis of symmetry. Indeed. So it's how far away. This is the x. I can never determine the y value before I find the x. We only have the x. I know where it happens, but I don't know how much it is yet. How do I know how much it is? Exactly. So the max height is g of, exactly. And please plug it in and tell me what you get. So what? Good. So how much is it? Do we have a number?
33.6625.
6625 feet. Anyone confirms the 33.66? Okay, I got confirmation. That's perfect. Part B. What is the maximum horizontal distance to the nearest 10 or the distance of the throw? So I'm doing this. That's the distance of the throw. About here, it was maximum, and then it hit the ground. I want to determine the distance of the throw. How do I get that? Look at the graph and tell me what that means. I need to determine
Where it's filled.
when When g of x is 0, perfect. The x-intercepts, very good. Because once it hits the ground, the height is 0. Very good, thank you, Tim. So negative 0.04 x squared plus 2.1 x plus 6.1 equals 0. What type of equation is this, and how do I address this? Once I identify it correctly, I have great chances of solving it correctly. Quadratic. And I will be using which method? We know 4. I want to complete the square. You should throw tomatoes at me. Right? Nobody's going to complete a square on something like this. However, I claim that this is not ready for quadratic formula. What do you think I am going to do? You may not want to do it, but I will do it. Yes, please, Marcus. Exactly. I refuse to solve a quadratic equation with quadratic formula or not with a negative leading coefficient. I agree. Thank you. Absolutely. And then I will start negative b. Very good. 2.1 squared. Minus minus. There is a minus and minus. Minus 4 times a times c over 2 times a. With the graphing calculator, I will do this. Parentheses for the top. 2.1 plus the square root. Parentheses. 2.1 squared plus 4 times 0.04. I want to calculate that as 0.16. You don't have to. You can put all three in order. Close the parenthesis. Go outside of the square root and divide by 0.08. If I want to determine the other one, I copy everything I wrote with second and entry. And it's very difficult for me with the software. Not very difficult, you know what I mean. But easier for you with a calculator. And I want to overwrite, change plus into a minus to find the other solution. So x is approximately 55.26 feet, and x approximately negative 2.76 feet, which I don't care for. Is the other x-intercept is possible, but it's behind me. I'm here. I'm throwing it. So that negative 2.76 is behind. So that's no use. So how far am I throwing this ball? How far away? 55.26 feet from where I'm standing. Part C. From what height was the shot released? Exactly. Because now I want to find the Y-intercept. Excellent. So G of 0, 0, 0, 6.1 feet. Very good. So the person who throw it, or it was thrown from 6.1 feet. Any questions for me? I'm sorry? Yes. So let's look at page 361. Again, so I'm looking here. This was, what was it? 58. 65. Let's look at 65 or 66. So 65 has the answer. Let's look at 66. Very good. Problem 66 on page 361. You have 200 feet of fencing to enclose a rectangular plot that borders on a river. So we are given the picture. Here's the river, and here is your plot, and you want to put flowers in there or something else. So here is the rectangular plot, and you have 200 feet. So you will start here, go all around and stop here. Because the problem says we do not want to, we don't need to fence the side along the river. If you do not fence the side along the river, find the length and width of the plot, and here's the key, that will maximize the area. What is the largest area that can be enclosed? So all we have is 200 feet of fencing. And we would like to find a way of enclosing this rectangular garden. Of course, I have to give it some names. I don't know how wide it should be, and I have no idea how long it should be. I know two things. I want to use it all because I have it. I don't want to keep part of it or save part of it. I want to use the entire 200 feet, and I want to find how long and how wide this rectangular garden should be so that I get the maximum out of it. Okay, so which two keywords do you think we are looking at here? Maximum is a keyword, and the other one is the maximum of what I want to determine. The area. So that's where I have to start. I cannot maximize something I don't have. I have to have something that I will say, oh, how do I maximize it? But I don't have it. So my starting point is where once again? At the area. So I denoted the length by x and the width by y. How do I write the area for this garden? Very good, awesome. So for now, leave it alone. This is what I am trying to find the maximum for. Good. Now, I do have a relationship between x and y. What is the relationship that I can write for x and y? Say it again. Yes. Awesome. How do I write that?
2x plus y equals 200.
Do you all agree with 2x plus y equals 200? Awesome. I have to start. I start here and I go all around and I end here. And I will not fence the side along the river. Agreed? Good. This is another very important piece. Now I look back at the area and I have a problem with the area. What is my problem with the area? It has how many variables in it?
2.
I don't know how to solve something like this. So I have to get rid of one of them. How do I get rid of one of them? Using what I have. Substitution. What? How? By, I'm sorry, 4? Awesome.
2x
Careful.
minus 200.
So I have a relationship now for y. Y depends on x. And I have it as negative 2x plus 200. And now please dictate my next step. So the area, can I say now that it will become a function of x? You don't have to write a of x. You can write f of x. You can write g of x. The name, it's up to you. I copy. And then in parentheses, what do I write? Of course, this doesn't tell me much. I will have to do what next? Awesome. How do I do this?
2x squared
Very good.
plus 200.
Yes. Now I stop and I look at the function. What type of function is this? Awesome. Does it have a max or a min?
Max.
How do I find the maximum? I only need one word.
V,
Okay, 2. Which, exactly. That is the point that will give us the maximum, right? So all I have to do is find the vertex. Find V. How do I find the x-coordinate? Can I read it? Is this completed? Is the square completed here? No. So I cannot read it. So how do I do it then? Exactly. Negative b over 2a, negative b over 2 times a.
Or
Careful.
negative.
Yes. And the answer is measurement unit. So this is the x. How do I get the y?
X.
So how much is the y? But this time the y is not the maximum. This is the y which is the length in the problem. This is a different y. What will this be?
2,
What does this, yes,
50.
awesome. But what will this mean? I know that y represents the length. But what will this quantity mean when I find it? The max what? The max? Exactly. That's what it will be. Right? This is a quadratic function. Once I find where the maximum is, since I know that this is the area, this is the area. Once I plug in a of 50, this will be the maximum area. It's the y coordinate of the vertex. Good. So how much is y? However, how did we create the area? Multiplying x and y. You don't have to plug 50 in here. You just multiply x by y and tell me what it is. The answer should be the same. 5, 0, and 2 more zeros. If you plug in 50 in here, you will have to get the same answer. So what will you say to the farmer? Here's the solution.
Flood insurance.
No. No. Okay, what will you tell him? Using your 200 feet of fencing, make sure that the length of the garden is exactly how much? Using your 200 feet of fencing, all of it, make sure that the length of the garden is 100 feet and width is 50 feet in order to get a very good maximum area possible with the given conditions, the 200 feet and fencing 3 sides, get a maximum area possible of 5,000 measurement unit. Thank you. So this is our recommendation to the farmer. Knowing that you only have 200 feet, and knowing that you are only fencing 3 sides, and knowing you want the maximum area, make sure that you measure correctly 50, 50, and 100. Because if you have 49, 49, and 102, you will not get the maximum area. Any deviation from 50, 50, and 100, it will not give you a maximum area. Because, right, this is when x is 50, and the height, I'm sorry, the maximum area is 5,000 square feet. If your 50 becomes 49 or becomes 51, look where your area will stay, not maximum. It will be up here or up here, but not up here. So do not deviate from the 50 and 50 and 100, because you're not going to get the maximum area. If you use 55, look where your maximum area will be that you are going to obtain. You're not going to get the maximum area unless you stay exactly where we are telling you. 50 in the width and 100 in the height. Any questions? The next section, any questions? Yes. Caitlin, you had a question? Anyone? No. The next section, this is not the way I present it. It's on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, roughly 14 pages. Okay? So if you bear with me, the first problem will probably take 15 minutes. The next one will take 3, and every subsequent problem will take a minute. But the first time, I have a lot to say. Okay? So in section 3.2, so please bear with me and pay attention. We're going to have enough examples, but the first one will be long because I have a lot of things to tell you. So section 3.2, polynomial functions. And you could ask, what about quadratic? What was that? Polynomial, degree 2. I agree. What about linear? What was that? Yes, polynomial, degree 1. So what are you talking about here? I'm talking about degree 3, 4, 5, 6, and so on and so forth. I'm not excluding the first degree and the second degree from the category of polynomials, but in this section we are dealing with more sophisticated polynomials than this, than the first two, linear and quadratic. There is a long list of things that we have to look at. Okay, so I'm going to list them. And then we'll go through all these with different problems. Number 1, domain. Number 2, X-Intercepts. And this is a word we have not used before, multiplicities. X-intercepts and multiplicity, plural, multiplicities. Number 3, Y-intercept. Number 4, degree. This is not the specific order we're going to look at, but I'm going to list all of them. 5, maximum possible number of turns. When we talk about turns, we really mean what? I'll put in parentheses. Yes, very good point you're making. Only the quadratic function has a vertex. We're done. No other function, but you're correct. Max or min, correct. But we will never talk about a vertex. Yes, just yes. We're not going to call it. So this is indeed max, min. 6. Values of the max, min. 7. Something we've never talked about. We did, but I just didn't mention the name. And behavior. And for number 6, I wanna put in parentheses so it's clear. Calculator, TI-84. We can't do that without the calculator. Okay? This is it. I should add here number 8, symmetry. We don't want to go through 13 pages to collect our information. So every little thing that you see listed here will be summarized in a table, in a chart, everything. Because otherwise we'll have to flip through 13 pages of work and we will not have all the information in front of us that will help us graph this function. So I'm going to start with a polynomial degree 3, and then polynomial degree 4. Once we understand the odd degree and the even degree, all these will be a breeze. Okay? Before we proceed, I want to look at odd degree and even degree. And this discussion here is only about end behavior. So I'm talking about 7 in preparation for what follows. Give me a polynomial of degree 1. I meant to say, give me a polynomial of odd degree that we know about. Very much, a lot, everything. What will you say? Exactly, a linear function, right? So an odd degree polynomial will be linear, right? A linear function. We know by now everything about it. What are the possibilities for a linear function? Case 1, right? Which means a positive slope, which means it's coming from what values? And it goes to which values? So what is the end? It's a fancy way of saying it. What is the end behavior of this function? It's negative infinity at this end and positive infinity at this end. So this is one option for a linear function, correct? Here's a second option for a linear function. There is nothing else. What would be the end behavior for this function coming from positive infinity and going to? All odd degree polynomial functions will do the same thing. All of them. So the linear function can look like this, coming from negative infinity and going to positive infinity, or not both. This, coming from positive infinity and going to negative infinity. What does this depend on? What does this depend on? Meaning, how do I know that this is the case? And how do I know that this is the case? What exactly? Which is the leading coefficient? Right? So here, if the slope or the leading coefficient is positive, it will be a positive trend. If it's negative, it will be a negative trend. Degree 3 will do the same thing. Degree 5 will do the same thing. Degree 7 will do the same thing. All of them will follow this. Of course, we'll do something else in the middle, but I'm talking about end behavior. Can anyone give us the simplest possible even degree polynomial function that by now, we dream about? Yes. So quadratic. What are the only two possibilities for a quadratic? Exactly, right? So what is the end behavior for such a quadratic function? To positive infinity. What is the other option? What is the end behavior for such a function? All even degree will do the same thing. It all depends on what? The leading coefficient again. So this is positive to positive or negative to negative infinity. And of course, the leading coefficient here is, if we understand this piece is done. Okay, if you have your book, I will ask you to open on page 378 and choose for us a third degree polynomial, cubic polynomial. Cubic means third degree. Okay, so we are on page 378. Anything you want from 41 through 64. 41 through 64, but it has to have degree 3. If you don't want to choose, I will. Which one? 42. Yes, 42 is a good one. Very good one. But I would like... We can do 42. The reason, you'll see in a minute why, because I need to talk. In that problem you picked, I cannot talk about multiplicities. Because all the x-intercepts will have this, when you factor out, you have x squared, x minus 4. Yeah, all three solutions will have multiplicity 1. So that's why I need to see the difference for the multiplicities. So let's choose another third degree. Yes, I see, 53 and 54. Okay, let me wake one up. Can anyone give us the degree of this polynomial? When I square x plus 1 squared, what degree do I get? Yes, I get x squared, right? When I multiply x squared by x, what degree do I get? 3. Is that clear? Okay, very good. So this is degree 3. I get my chart going, and I will go through the list. So here's my list of 7 items. We established the degree already, correct? Now I would like the domain. What is the domain of a polynomial function? Forever. Very good. So I'm done with the domain. I want to find the Y-intercept because that's easy. How do I find the Y-intercept for any function? Exactly. I find f of 0. Let's do it together. 0 plus 1. 1 squared. 0 minus 3. Negative 3 times 1. What is the ordered pair? So we're done with the Y-intercept. I'm here now. Maximum possible number of turns or possible number of max-min is always degree minus 1. What is the degree of a linear function? 1. How much is 1 minus 1? How many terms are possible in a linear function, max, min? Of course. Quadratic function, what is the degree?
2,
How many possible max, min a quadratic function can have forever?
1,
Degree 2 minus 1. We are in degree.
3.
How many maximum? Doesn't have to have any. But what is the maximum possible number of terms?
2.
Yes, 3 minus 1 equals 2. Max possible number of terms. So now this is done. And behavior. It's degree 3. Does it behave like the linear function, or does it behave like a quadratic function? Like a linear, because it's degree 1. It's degree 3, behaves like the linear. It's odd. Does it have this end behavior, or does it have this end behavior?
It has the,
How do I know?
because the leading coefficient.
Because the leading coefficient is positive. So what will I write here? It's coming from very good, and it's going to very good, awesome. So I'm done with the end behavior. The last thing I have is X-intercepts and their multiplicities. How do I get the X-intercepts? Very good, awesome. So I have f of x equals 0. So then I have x plus 1 squared times x minus 3 equals 0. Since you told me that the degree is 3, how many solutions do I have to show? Mandatory 3. Very good. So 1, 2, 3. Can anyone give us the solutions? That's why I picked a problem that was already factored. Can anyone give us those 3 solutions?
-1, 1, 3.
So x equals
X equals -1.
good.
X equals 1.
1 plus 1 times 1 minus 3 will not be 0 ever. 3. 2 plus 1, 2 minus 3 will not be 0. Where is the third solution? 0 plus 1, 0 minus 3 will not be 0. It's 1 minus 3 times -3. What does this mean? Say it again. What?
Twice as many -1.
Twice -1, indeed. Because it's x plus 1 times x plus 1. You cannot make it up, right? It's there. It's x plus 1 times x plus 1 times x minus 3. Okay. We found the x-intercepts. Now I'm going to explain this. It's the last thing that we need, and then we're done.
The X-intercepts. So will we write -1 twice?
Yes, and I'll explain what it is. Yes, right now. Right now. Okay. How many times does x equals 3 appear as the x-intercept? Multiplicity 1. How many times does x equals -1 appear as a solution, or as a 0, or as an x-intercept? Twice. What do you think I'm going to write?
Multiplicity 2.
Why is this so important? So let's look at multiplicities now. Now you understand multiplicities are only for x-intercepts. Only for the zeros of the function. There is nothing else. Okay. So there are 2 possibilities. Odd and even. We did get an odd multiplicity, right? So x equals 3 has an odd multiplicity. Would you agree?